today we're going to look at what are called similar shapes, which are shapes that look the same but are a little bit bigger or a little bit smaller. Okay, similar shapes have sides that are different lengths, but all the interior angles are the same. And there's going to be some kind of consistent scale factor across the corresponding sides. And so understanding how we come up with that scale factor is going to help you decide, number one, whether or not two shapes are similar or not. And then when they are, we can use the side lengths from one to figure out the other if we know what that scale factor is. So let's take a look at these two rectangles. We've got rectangle A and B. And they are similar. If we look at the dimensions between these, the dimensions of these two rectangles, the smaller one is a 1/2, and the larger one is a 2/4. Notice here that there is a constant value that I could multiply each of the side lengths by to get the other rectangle. So like if I wanted to find the connection between the widths of the rectangle, going from 1 to 2, notice here I'm just multiplying by 2. Right? 1 times 2 is 2. Similarly, 2 times 2 is 4. So we have the same scale factor being multiplied on the length as we do the width. And so when that happens, and you have two shapes that are set up like that, they're considered similar. Okay, that's kind of the key phrase. They're not the same. If the shapes were exactly the same, we would call them congruent. But if the side lengths are all proportional, then we call them similar. So the scale factor here is 2. And you could also use that scale factor going backwards. Like if you're going from a larger shape to a smaller shape, you can still find some number that you're multiplying by the different side lengths. It's just going to be a number smaller than 1. So like if I want to go from B to A instead of A to B, go from A to B, I'm multiplying by 2. But if I want to take some scale factor to scale down figure B and get figure A, I'd have to multiply by a number smaller than 1, in this case 1/2. 2 times 1/2 is 1, 4 times 1/2 is 2. So if you wanted to go B to A, you would say the scale factor was 1/2. So I'm actually going to add that little bullet point here, that the scale factor from B to A is 1/2. Okay, so you're multiplying by 2 if you're going from the smaller to the bigger rectangle, but multiplying by 1/2 if you're going backwards. So first, we're just going to look at a few examples where we're trying to identify what the scale factor is, and then we'll go on and start solving some similar shapes. So number 1 says, what is the scale factor from A to B? So if we're going from A to B, what we're interested in is what number is being multiplied, what constant, by each of the dimensions to get the dimensions of the larger shape. So if this smaller triangle is a 1/2, and the larger rectangle triangle is a 3 by 1, 2, 3, 4, 5, 6. Is there a consistent scale factor there? Like what number am I multiplying the smaller sides by to get the larger sides in this case? 3. Yeah, 1 times 3 is 3. 2 times 3 is 6. Right? 1 times 3 is 3. 2 times 3 is 6. So that would be the scale factor. We can also use that to determine whether or not these shapes are similar at all. Like if there wasn't a consistent scale factor, like let's say the larger shape was like a 3/5 or something like that, then they would not be considered similar. That scale factor has to be consistent for all the different side lengths. So I'll just say these two shapes are similar, and the scale factor from A to B is 3. That figure over to the right, those two shapes look like they could be similar, But in geometry, you never want to make any assumptions just based on what you are looking at, because these diagrams may not be drawn to scale. So you never really want to just go based on what the picture looks like, but rather what are the numbers saying? Yeah, what is going on with the numbers? So if we want to, this question is like, are they actually similar figures? So we can try to find what that scale factor is. If I'm going to take this vertical side 5 centimeters to this larger blue triangle 15 centimeters, that would have a scale factor of 3 because 5 times 3 is 15. But if I multiply 7 by 3, that is not going to give me 20. Right? 7 by 3 would give me 21. The scale factor here would actually be 20 over 7. It's kind of a weird fraction here, but that's because 20 is not a multiple of 7. So we'd have to multiply by 20 over 7. And typically you're not going to be asked to like necessarily find that, but you need to be able to say whether or not two shapes are similar. And so I do not have a consistent scale factor here, so no, they're not similar. And that's because they have a different scale factor. Now, just identifying whether or not two shapes are similar, that's what's going to be one component of what you're going to be expected to do. But the sort of the bigger picture here, the sort of the more common problem type that you're going to see is asking you to like solve, like if we assume two shapes are similar and we've got some information about one of them, what can we do to find the missing side lengths of another? And so if you've got like, let's say we've got two similar shapes, and we have 3 of the 4 dimensions, meaning like let's say we have like the base and height of one and just the base of another. What we can do is set up a proportion and solve that proportion with the cross products property to find that missing side length. So the sort of these steps that I want you to take when you're trying to find a missing side length and you do have similar figures. Number one, figure out like which pairs of sides correspond. You want to make sure that you're scaling up the correct side. So, you want to make sure like the bases correspond or the heights correspond or however it's oriented. And we'll see a few examples here where we have to do that. We want to figure out what sides match up with on both figures. Then you want to set up a proportion. Okay, this is going to be 2 equal ratios, 2 equal fractions. So this will be kind of something similar to when we talked about how to solve proportions. You're going to have like 1 unknown and 3 knowns, and then we can use the cross products property to solve that equation, which is like cross multiplication. Sometimes it's called that. So let's just go through a couple of these problems so you can kind of see how it's actually going to play out here. So this first one says, find the length of QR, which is that vertical side on the blue rectangle. And we're going to assume these are similar shapes, okay? Meaning that there should be some consistent scale factor between the smaller and the larger shape. So to find that scale factor, you need to figure out what am I multiplying by? Like if I'm going from side AB to side PQ here, what number am I multiplying by to change 9 into 27? 3, yeah. So my scale factor here is going to be 3. So that same scale factor is going to be used here. And 4 times 3 is 12. Now, that's one way how you can figure this out, right, is to identify that scale factor and simply just multiply the other side length on it. But what I want to do is show you that, let's say like the scale factor is a little too hard to figure out. Like this one's not so bad because 27 is a pretty easy multiple. It's a small multiple of 9. But if the numbers were decimals, or maybe like it's not like a clean multiplier there. Like what if the multiplier is like 2.71 or something like that, where it wouldn't be so obvious at a glance what it is? In that case, you'd want to set up a proportion. And even though we know what the answer is going to be here, I want to show you how that would work. So you want to set up 2 equal fractions. One is going to relate the sides that you know, and one's going to relate where we know one of the side but not the other. So in this case, um, I would say something like 9 is to 27. Okay, so like that horizontal side is equal to 4 is to what? And that's that length of QR. Okay, that x. It's not called x, but that unknown there. So notice here I've got the red triangle here and here, and the blue triangle here and here. Okay, so like the numerators have to correspond to each other, and so do the denominators. And then within the individual fractions, you're comparing one side on one shape to the corresponding side on the other shape. So 9 centimeters is the horizontal side, and we're going to put that over 27 because that's the other horizontal side. And so to solve a proportion like this, we are going to use the cross products property. So we're going to multiply QR by 9, and we're going to multiply 4 times 27. So 9 times this length of QR equals 4 times 27. And you're probably going to want a calculator for 4 times 27. Let's see what that would be. 108. So 9 times that side length QR equals 108. And then if we divide both sides by 9, 108 divided by 9, we should get the answer that we had earlier, which is 12. Now, again, if you can figure out what the scale factor is, you don't necessarily have to use the proportion to solve it. But if you cannot figure out what the scale factor is, either because it's like too hard or you just don't feel like it, you can always fall back on that proportion method. So like on the next example for number 4, you might be able to figure out what that scale factor is going from 12.5 to 25. Whatever this is being multiplied by, or actually we're going to have to go the other direction, huh? We're going to go from 25 to 12.5 so that we can go 18 to whatever BC is. And it might not be super obvious what you're multiplying by. Yeah, I mean, I don't know. Can any of y'all figure out what that scale factor would be? Like, how do I go from 25 to 12.5? Yeah, it might not be super obvious, which is okay. When it's not obvious, that's where you're going to fall back on the scale, on the proportion. So here, I'll start with like the 25 to 12.5. So 25 is to 12.5 as 18 is to X, or is to side BC. Now I can cross multiply. So 12.5 times 18, 25 times length of BC. So 25 times that length of BC equals 18 times 12.5. Do a little calculator action here. 18 times 12 and a half is 225. So this one's going to work out pretty good. We need to divide both sides by 25. And looks like we get 9 here. Now, if you did happen to pick up on the scale factor here, 12.5 is half of 25. Right? If I multiply 25 by 1/2, I'm going to get 12.5. And if you do catch that before you do any of this proportion stuff, then you can come up with the answer pretty easily, because half of 18 is 9. So you can always check with that scale factor also. Um, any questions about either one of those? All right, so I just want to show you two other examples where we have similar shapes because the corresponding sides might not be super obvious, but I want to make clear when you see these kinds of examples what you should do with them. So let's say we have one like this. If your triangles are oriented like this, where it's really like we've got two parallel lines, so like this would be parallel to this, and we've got two transversals going through them, basically just lines cutting through those parallel lines. As far as like which side length corresponds to which, this is a little tricky on here. But in this case, the 4 is going to correspond to the 10, and the 5 corresponds to the x. Okay, I don't think that's super obvious, but this kind of falls back on some of the properties that you learned back in geometry with regarding parallel lines. Like, for example, when you have a set of parallel lines, what are called the opposite interior angles, they're congruent. And what I mean by that is that this angle will be the same as this angle. Okay, those are called alternate interior angles. Right? Well, you're not going to get like tested on all that vocabulary, but also angle E here should be the same as angle B. So you can kind of see with those properties why like the corresponding sides are got like reversed on each of the triangles. So at any rate, the 4 centimeters, this side length is going to correspond, and I'll do a little color coordination here, to the 10, and the 5 is going to correspond to the x. So when we set up our proportion here, it should be something like 4 is to 10 as 5 is to what? And so that's why it's very important that you get those corresponding sides correct, because otherwise your fractions are going to be kind of messed up if you're relating the wrong sides with each other. So we can solve this the same way we solve the other problems with cross multiplication. So we're going to multiply 4 times x and 5 times 10. 5 times 10 is 50. And then we just need to divide both sides by 4. And we get x equals, what would that be? 1. Oh, that's going to be a decimal, isn't it? 50 divided by 4 is 12.5. Any questions about number 5? All right, I've got one more example for you. Number 6 here is a little bit different, where we've got one triangle sort of embedded into the other triangle. Let me zoom out a little bit so you can see both of these. So anytime you've got a situation like this could be another one where finding the corresponding sides can be a little tricky. But what I usually recommend on a problem like this is to actually redraw the diagram, but with the triangles split apart, as opposed to trying to see it all at once. So like the triangle that's kind of on the top here, this one right here, I'm just going to draw that over to the side. Just redraw it with the sides labeled 5 and 7. That's all we really know there, right? And then the bigger triangle, so like this one, is going to be your second triangle. All right, so if I try to redraw that, and I think redrawing it will really help you make sure you're getting the right side lengths. The bottom side length on there is x. Get all that fixed up. There we go. Bottom side length is x, and then that side going up on the left is actually 8. And the reason why it's 8 is because from D to E is 3 centimeters, and then from E to A is 5 centimeters. So it doesn't explicitly give you that side length. You've got to infer it from the given information. But 3 plus 5 is 8, so we know that one's got to be 8. So now we're going to try to find x. And so again, we're going to have to set up a proportion to be able to find this, because I don't think the scale factor is super obvious, right? Like 5 times what is 8? Some kind of decimal. It's not going to be a whole number. And so in these cases, it really doesn't make sense to try to attack it from that angle and try to find the scale factor. Instead, we'll just set up our proportion and solve it like we solve all the other ones. So here we've got 5 is to 8 as 7 is to x. Now, there is a little bit of freedom in how you set up these proportions. Basically, if you imagine like these 4 positions where we have numbers like the 5, 8, 7, x, all the, like, as long as you're consistent about what is corresponding either across or down, you can rewrite that in a lot of different ways. Like, the way I like to think about it is like that relationship's fixed, but you can always like sort of rotate the proportion. By that I mean like just like move every number like one position. Like if you're gonna like rotate it like a circle, like in other words, like you could also set it up as like 7 over 5 equals x over 8, where every number is sort of like rotated 90 degrees. You could also set it up as like x over 7 equals 8 over 5. There's a bunch of different ways you could set this up. You'll get the same answer no matter, as long as the numerators and the denominators are correspond correctly, and that you've got the same kind of correspondence going on vertically. You can't really set it up wrong if you're doing it that way. So all 3 of those would be fine. I'm just going to stick with the first one that I got here, but just know that you've got a little bit of freedom in how you set up this proportion. You just want to make sure the most important thing is that the sides are, that they do correspond to each other. So we've got 5 times x, 7 times 8, 7 times 8 is 56. And then we'll divide both sides by 5, and this is not going to divide evenly, so we are going to get a decimal here. So get x equals 56 over 5 is 11.2. So yeah, sort of big idea today. Want to make sure that you can set up and solve for these similar shapes. Make sure you understand what a scale factor is and how that plays in. And really, like, I think the hardest part is going to just be making sure that your proportion is set up correctly. Y'all know how to cross multiply and divide. That part doesn't worry me at all. I just want to make sure that when you set it up, you've got those corresponding sides next to each other or across. You can set it up either way. Anyone have any questions about similar figures? All right, well, you've got the last